Hello, ladies and gentlemen, and welcome back for more of the 2002 Gauss paper, and that is the grade 7 Gauss. We're up to question 21, which is rather short in terms of its statement. 5 people are in a room for a meeting. Okay, that happens in real life. When the meeting ends, each person shakes hands with each of the other people in the room exactly once. The total number of handshakes that occurs is... Okay. I like this question. It's a counting style question. And if you're up on your more advanced mathematics, this question is a breeze for you. So what I mean by this, and I'll just state it quickly and give you a little bit of foreshadowing for combinatorics, so this is my little plug for combinatorics. Look how easy it is to solve it with this. And many of you are not going to understand the notation. I include it just so you can look back on this fondly someday when you do understand it. So we have 5 people in the room. It takes 2 people to shake hands, and we want no duplications. So that's going to be 5 people choose 2 people. So how many ways can we choose 2 out of 5? And that pretty quickly comes out to be 10. You can use a calculator for that, or you can say it's 5 factorial over 2 factorial times 3 factorial, which is 120 over 2 times 6. So, using a bit of advanced math, which many of you watching this probably won't get, the answer is clearly B. But this is the grade 7 level contest, so how about we approach it in a grade 7 level way? That was just my little pitch for learning math beyond your years. Solved question 21. That took us 5 seconds. Probably 10 seconds, but it would have been 5 if I didn't need to explain my notation a little bit. So, we're going to ignore this. Right? If you know it, fantastic. If you don't be scared. I erased it. I got rid of it. It's gone. Actually, let's erase it. It's gone. And hopefully one year, if you stick with it, you're going to end up seeing this sort of stuff, combinatorics. But, suppose we wanted to do this in a more reasonable way. Well, there's a couple things we could do. But the one I really like is I like giving everybody names. So let A, B, C, D, and E be the people. Now, if you've done these contests as long as I have, you instinctively start giving A a name like Alphonse, and B a name like Beryl, and C would be Colleen, and D would be, Daniel or David, and E would be Ava. There are some names that they really like on these contests. So if I let A, B, C, D, and E be these people, what possible handshakes could I have? Well, everyone needs to shake hands with everyone else, basically. So A needs to shake hands with B. And so I'll list that as AB. And that's a handshake. Now, no matter what I do, I should not have any other AB handshakes, right? I've already counted. A has already shaken B's hand, and each person shakes hands with each other person in the room exactly once. So A and B have shaken hands. They're not going to do it again. Okay? And A could shake hands with C. A could shake hands with D, and A could shake hands with E. And these are all the handshakes with person A. Okay, so that's great. How about person B? Well, who's left in the room for B to shake hands with? Well, A. And they could shake hands with C, and they could shake hands with D, and they could shake hands with E. Now stop for a second and think, does this make sense? Does this agree with what the question says? No, we have one too many handshakes. I already said A and B have already shaken hands. They shook hands up here. They're not going to shake hands again. So even if B's the one maybe the first person's the one extending their hand out, and the second person is the one accepting the handshake, no matter what, A has already shaken B's hand. They're not going to do it again, so we just get 3 handshakes that involve B that have not already been counted. A and B already shook hands, so we don't count that again. How about handshakes with C? Well, can't shake hands with A or with B. Those have already been counted, but C hasn't shaken hands with D or E yet. And finally, D will shake hands with E. So we have 4 handshakes with A, 3 with B, 2 with C, and 1 with D. So 4 plus 3 plus 2 plus 1, and that is 10. And I think I sort of predicted that earlier with my more advanced math. Now, we might think, hey, there's only 3 handshakes with B. But, in fact, there's a 4th one up here. It's hidden because it's A shaking hands with B. And, it might look like, D's not really shaking many hands. He's really only shaking E's hand. But D already shook C's hand, already shook B's hand, and already shook A's hand. So everyone does shake everyone else's hand. So if we look at C, there will be 4 handshakes involving C. There's 1, 2, 3, and 4. Okay? So everyone does shake hands with the 4 other people in the room. And there's no duplications. We have AB, we don't have BA. We have CD, we don't have DC. Okay? We have BC, we don't have CB. There are no duplicates for a handshake. So, everyone shakes hands with everyone else. Fantastic. And there are no duplicates. Well, that's exactly what we're asking for. Each person shakes hands with each of the other people, so each of the 4 other people in the room, exactly once. So our total number of handshakes is 10, and that's going to be B. Okay. And I think this is a much more reasonable way to do it. Now we can actually see, and we can count, and we can make sure A is definitely just shaking hands with B once. There is no BA. There is no BA later on, or another duplicate AB or anything like that. So by listing them out, by giving names to the people, we can actually verify, yeah, B is shaking hands with everyone exactly once. A is shaking hands with everyone exactly once. And in this way we get 4, 3, 2, and 1, which gives us a total answer of 10. So in the next video, we're going to take a look at question number 22, and I'll see you guys then. But, of course, make sure to give it a try first, and we'll tackle it together in the next video.